Welcome to part 7 of the Koch Fractals in Unity tutorial by PeerPlay. From this part on, we will create a system based on the Koch generator using trails instead of the line renderer. I'm going to show you a system that allows you to create some very cool visuals using the Koch Fractals. I've created a new scene for this, and we're going to place everything inside of a new folder, and we'll call that trails. So let's create a new folder, and we'll call this Koch trail. Now let's add a new script, C# script, and we're going to call this Koch trail. Now we're going to create a prefab that contains a trail renderer that we can instantiate with the Koch trail script. So let's create an empty game object, and we're going to rename this to trail prefab. And we'll add a component to this of a trail renderer. Now we're going to save this as a prefab, so drag and drop this into the folder, and there we've got our prefab. Now let's also create a new material, and we'll call this the Koch trail material. And what we're going to do with this is set it, instead of using opaque, we're going to use transparent. And let's take on the emission. Now that we're all set, let's open up the Koch trail script. Now first of all, we're not going to inherit from mono behavior, but we're going to inherit from the Koch generator. So let's type here Koch generator. And let me save this script and go back to Unity for a moment. Let's remove this trail prefab, and we're going to create an empty, and we'll call this the Koch trail. Now drag and drop the Koch trail script onto this, and here we've got our Koch trail script. Now let me set the size of the initiator a little bit higher, so I'll set it to 10. Set it to its z-axis. Let me zoom in. What we're going to do is, based on the amount of initiator points, in this example 3 points, as we've got a triangle, we're going to instantiate a new trail on each of these points. So one trail will start at this point, one trail will start at this point, and one trail will start at this point. And they will move based on the music along their points to the new point. So if we change this from a triangle to an octagon, this would mean that we would instantiate 8 different trails at each of these points, and they're all going around following the path. And in our script we will add some different behaviors to the individual trails. So let's open up the Koch trail script again. So it's actually going to be quite a lot of code to write, and I'm going to try to pick up the pace here a little bit. So first of all, what we need is to make this run on audio. So let's type a public audio peer, and we'll call this audio peer. Let me actually put this onto a header. So we're going to type a header, and we'll call this header audio. Now another thing we need that we've also done in the Kochline script is that we add some audio bands. So let's type a public integer, and we'll call this audio band, and we'll make that an array. Now let's make another header, and we're going to call this header the trail properties. So we'll say header, and we'll call this trail properties. And we need to make a reference to our trail prefab. So let's type a public game object, and we're going to call this the trail prefab. Now in the start function we want to instantiate trails based on the initiator point amount. And for all these trails we want to keep track of certain values of the trails. So for that I am going to create a new class which holds everything that we need to keep track of. So let's create a public class inside of this class, and we're going to call this class the trail object. Now the first reference we need in our trail object is a game object. So let's say public game object, and we'll call this GO for game object, and we're going to do a get set here. Let me quickly copy paste the get set here, and let's go to the new line. And we're also going to need a trail renderer, and we'll call this trail renderer trail, and we'll do a get set there as well. Now, as we're going to make these trails lerp through the positions list, we need to have a current target number and we need to have a target position. So we're going to add a public integer and we're going to call this the current target num, which is also having a get set. And we also need a public vector3, and that will be the target position. And now the last thing I'm going to add is a color, so we can specify that all these different trails will have a different color that we can set with a gradient. We'll add that later. So a public color, and we'll call this the emission color, and we'll also do a get set. Now there we've got our class. And now we're going to create a list containing these trail objects. So let's type a public list, and the list is based on the trail object class, and we'll call this trail. Now let's say hide in inspector. Now let's add some properties to the trail properties that we can apply to our trail. And some property that a trail renderer contains is a width curve. So we're going to add a public animation curve so we can set the width curve of the trail. So animation curve, and we'll call this the trail width curve. Now another thing that the trail renderer contains is an end cap vertices, which specifies how many vertices are at the end of the trail. So it becomes a little bit more roundish. So let's type a public integer, and we're going to call this the trail and cap vertices. Now let's make that a range actually. So type range, and it's going to be a range between 0 and 8. Now we've created a material for the trail renderer, so let's create a reference to that. Public material, and we'll call this the trail material. And we're also going to set different colors to each of these trails, and for that we're going to use a gradient so we can set all the colors at once, and we'll call this the trail color. Now let's scroll down to the start function, and the first thing we're going to do in the start function is we need to declare that the trail is a new list. So we're going to say trail is a new list of a trail object. And now we're going to create a for loop to loop through all of the initiator points and instantiate our trails and fill the trail list with our trails and apply all the properties to it. So let's say a for loop for int I is 0, I is less than the initiator point amount, I++. And we'll start by instantiating our trail instance. So let's say game object. We're going to call this a trail instance, and it's going to be casted to a game object instantiate. Now what do we want to instantiate? We want to get the trail prefab that we created, so we'll say trail prefab. Now here we need to fill in a position, and we don't have yet the correct calculations of the correct position, but we'll do that at the end of this for loop. For now I'll just type a transform dot position. And for the rotation we'll just use quaternion dot identity, and we can set a parent for it as well, and we'll make it a parent of this transform. So this dot transform, and this will make sure that the instantiated object will be a child of this object. Now let's create a new trail object in which we will place all of the properties, and we'll link this game object to the trail object. So let's type trail object, and we'll call this trail object instance, and it's going to be a new trail object. Now we can talk to this trail object instance. So let's type trail object instance dot its go, which is the game object, is going to be the trail instance. Now let's create a reference to the trail renderer. So we're going to say trail object instance dot its trail. It's going to be trail instance dot get component of its trail renderer. Now we're going to create a new material for this trail object instance. So we're going to say trail object instance dot trail dot its material is going to be a new material, and we'll instantiate here the trail material that we'll select in the inspector. Now let's set the emission color of this trail object. So we're going to say trail object instance dot its emission color is going to be, and here we're going to get the trail color gradient, and we're going to evaluate on that gradient, and based on where we are in this loop we're going to get a different color from the gradient. So we'll say I multiplied by the entire length of the gradient, which is 1, divided by the initiator point amount. Let's save this script for a moment and let's see what this does. And apparently I made some errors, so let's fix those. This shouldn't be a minus, this should be an equal sign, and here I've done this wrong because the array clarification must be there. Now let's save this again. And here we've got the trail color. So if I create a gradient, then the first point will have this blue color and the last point will have this yellow color and anything in between. So let's continue in the script, and we're going to also add the end cap vertices. So let's type again trail object instance dot its trail, and we're going to set the number of cap vertices, and that is going to be our trail end cap vertices. Now what we need to set is the instantiate positions and the target positions. And as we are having a couple of different things like using Bezier curves or not using Bezier curves, and we have some different generations going on, we need to take those into account. So first of all, I'm going to create a private vector3, which we'll call the instantiate position. Now let's create an if statement if the generation count is above 0. So if generation count is above 0, then we're going to do something, and else we're going to do something else. Let me first specify the else statement. So if there are no generations, so it's just the initiator points, we can simply say that the instantiate position is going to be the position of its current loop amount. And for the current target num, we can say that it's this position plus 1. So let's say trail object instance dot its current target num is going to be I plus 1. Now with this information we can set the target position, so we'll say trail object instance dot target position is going to be the position, and which position do we want? We want to get the trail object instance dot its current target num. Now outside of the else statement we can say that the trail object instance dot its game object dot its transform dot its local position is going to be the instantiate position. And finally we'll add the trail object instance to our trail list. So let's say trail dot add, and we're going to add here the trail object instance. If the generation count is above 0, then the position list will be greater than the amount of initiator points. So we need to divide that position list by the initiator point amount, so we get the correct positions for all of the trails. And for that we need some kind of a step size, so I'm going to say a integer and we'll call this step. Now another thing we need to take into account is that either we're using the Bezier curves or we're not using any Bezier curves. So let's make an if statement if we are using the Bezier curves. If we are using them, do this, and if we're not using the Bezier curves, do this. Now if we're using the Bezier curves, we need to set the step size, and the step size is going to be the Bezier position, its length, divided by the initiator point amount. And the same thing goes for if we're not using the Bezier curves, then we'll set the step size is equal to the position list dot its length divided by the initiator point amount. Now we're going to set the instantiate position. So instantiate position is going to be the Bezier position. And which Bezier position do we want? We want its I value multiplied by the step amount. And the same thing goes for the, if we're not using the Bezier curves, we're going to set the instantiate position to become the position list of its I multiplied by the step size. Now we need to set the current target num. So we'll say that the trail object instance dot its current target num is going to be I multiplied by step plus 1. And that is exactly the same in the else statement, so I'll just copy paste this here. Now we just need the target position, so the trail object instance dot its target position is going to be the Bezier position. And which position do we want? We want to get the trail object instance dot its current target num. And the same thing goes for the else statement, but with the difference that we're not using the Bezier position, but we're using the position. Now that we've set up the start function, let's also add some movement to these trails in the update. So let's create a new void, and I'm going to call this void movement. And we're going to call this movement in the update. And let's scroll to the top and let's add two more variables. I'm going to call these private variables. And the first variable we need is a speed. So let's call this a private float, and we'll call this lerp pause speed. And we'll use the same speed for all of the trails in our system. And we'll also add a private float, and we'll call this distance snap. And we're going to use this distance snap to see if we're really near to our target position, and then we're going to snap to it and go to our next position. So let's scroll back down to the movement function, and we're going to add a for loop. So in the start function, we've made sure that the trail list is filled with all of the trails that we've got. So we're going to do a for loop on that trail count. So for int I is 0, I is less than the trail dot count I plus plus. So first of all, we're going to make our trail move towards the target position using the vector3 dot move towards. So let's write the trail I dot its game object dot its transform dot its local position is going to be a vector3 dot move towards. And this requires its current position, its target position, and its speed on which we want to do this. So its current position is going to be just the trail I dot its game object dot its transform dot its local position. And we're going towards its target position, so we'll say trail I dot its target position. And with what speed do we want to move? We want to do this by time dot delta time multiplied by the alert pause speed. Now we need to make a check what the distance is from its current position to its target position, and if it's closer than a certain amount, it should snap to that position and go to its next position in the loop. And also, if it's at the last position in the loop, we should go back to the first position again. So let's write that out. So first of all, I'm going to do a distance check on the distance snap. So distance snap is going to be a vector3 dot distance. So we want to get its local position, so we'll get the trail I dot game object dot transform dot local position. towards the target position of the trail. So we'll say trail again, dot its target position. Now we're going to check if that distance snap is under a certain value. So if this distance snap is underneath a value of, and I'll just be saying here 0.05, and here we'll set the current local position to the target position. So we'll get the trail I dot gameObject dot transform dot its local position is going to be the trail I dot its target position. And here we need to check if we are at the last position, and if we are, we need to snap back to the first position again, and we need to take into account that we're using either Bezier curves or no Bezier curves. So we're going to make an if statement, and if we are using the Bezier curves and we're having a generation count above 1, so say generation count is above 0, then we're going to do something, and else we're going to do something else. So if we're using the Bezier curves, we need to check if our current target number is lower than the Bezier position length. Then we're going to set the trail I dot its current target number to plus is 1. Else we're going to set the trail I dot its current target num to become 1. Now outside of these if and else statements, we're going to set the target position to become the current target number. So we're going to say that trail I dot its target position is going to be the Bezier position of trail I dot its current target number. Now let's copy paste these statements, and we're going to paste them at the else statement. And the only thing we need to change here is the Bezier position is becoming the position. And here we're not going to get the Bezier position, but we're going to get the target position. Now there's just one more thing we need to do to make our trails move, and that is to set our lure pulse speed. And for that we're going to create a new variable. Underneath the header of audio, we're going to create a public vector2, which will become a minimum maximum speed that we can set. So let's call this speed min max. Now let's scroll down to the movement, and at the top of movement we're going to set the lure pulse speed. So we're going to say lure pulse speed is going to be a mathf.lerp, and we're going to lerp from the speed min max.x to the speed min max.y. And for this example, I'm just going to set the speed based on the total amount of amplitude of the audio that's incoming. So we're going to get the audio pair dot amplitude. Now with that in place, let's save the script and go back to Unity. And we still need to specify all the variables in this Koch trail. So first of all, we've got the generator. So let's create a generator. And we're going to start at 0. And we're going towards 0. Inside here, I'm going to set this key to be at the time of 0.5 at a value of 0.25. I'll set the value here at 0, and I'll set the time here at 0.33. And I'll here set the time at 0.66, and I'll set the value at 0. Let's create all these handles to become linear. So this is going to be our curve. Let's create 2 generations. And the first generation is going to go outwards with a scale of 1. And the second one is going to go outwards as well with a scale of 1 as well. Let's tick off the use Bezier curves for now. And we're going to set the trail width curve. So let me create another curve here. And we're going from 1 to 0. We can set the end cap vertices. I'm going to set that at 4. We're not using the audio band yet, So we can skip that for now, and we're going to set the min and max speed. So let's say that the minimum is 0 and the maximum speed will be 250. In the next part we will also apply the trail time and the trail width on audio, and also a trail color. But for now we need to set that into the trail prefab, because otherwise it will be a very long time, because this will have a time of 5 seconds. So I'm going to change this to 0.2. The minimum vertex distance will be 0.01, and the width will make the width of 0.3 or something. Let's check out the result of this script. So here we've got now 8 trails that are following the curve and keep on moving on the beat of the music. So if we would change this to, for example, a triangle, and let's use the Bezier curves. Let's quickly change this a little bit to minus, and let's do this outwards with outwards of 2. Let's see what that looks like. So you get some pretty cool results in here with these trails. Well, I see that I haven't applied the trail width curve to them, so let's change that quickly in the script. I forgot to do that. So in this for loop we are also going to set the trail object instance dot trail dot curve width curve is going to be the trail width curve. Let's save that again and go back. And now the trail width curve should be applied to it. And we'll see that even better if I make them a little bit more of a width. So let's make it 0.6. Now you can see that they are very wide at the start and very narrow at the end. Let's actually see the result of all the different Koch trails with different initiators. So I'm going to add a square, I'm going to add a pentagon, a heptagon, a hexagon as well, and I'll also add the octagon. Let's see what that looks like. They're all reacting to a Bezier curve, so let's see. Well, let's actually change all of these to one generation, and let's make the maximum speed to 100. I think this looks pretty cool. I'm going to play this and see the result of what we've got so far. In the next part we will apply colors, width and speed variables on audio to the trails and start building some cool compositions. For now I want to thank you for following this tutorial. To support me creating these tutorials for free, you can become a patron at my Patreon and get access to all source code. Don't forget to like or subscribe, and I'll see you in the next one.